Consider the phase shifter circuit shown. The input voltage is described by the expression V equals 10 sine 200t given in volts. Assuming that the inductance is 500 millihenry, find the value of the resistance such that the output voltage lags behind the input voltage by 30 degrees and the amplitude of the output voltage. As you can see in this case, the output voltage is nothing else than the voltage across the resistor. So the problem gives us how the voltage provided by the source changes with time, which means that we implicitly know the maximum value of the voltage across the source, 10 volts, and the angular frequency, omega, 200 radians per second. It gives us the inductance as 500 millihenry and the phase angle between the voltage across the resistor and the voltage in the circuit. We need to find the resistance. Well, let's draw a phasor diagram for this simple circuit and see if we can find the resistance using the phasor diagram. And to make the phasor diagram even simpler, let's consider that the current, which usually makes an angle with the horizontal axis, in this case at time t equals 0, is totally along the horizontal axis. So if the current is totally along the horizontal axis, that means that the voltage across the resistor, which is always in phase with the current, will also be along the horizontal axis. So this is the phasor for the voltage across the resistor. Now, the voltage across the inductor is a phasor that is pi over 2 ahead of the current in the circuit. So the voltage across the inductor phasor will be perpendicular to the phasor for the voltage across the resistor. The sum of these two phasors will give me the phasor for the source. All I have to do is add them up, and don't forget you add them up as if they are vectors. You build a parallelogram, and you draw the resultant. And this phasor V represents the phasor for the voltage across the source. Now what the problem tells me is that the voltage across the resistor is 30 degrees behind the voltage across the source, which means that this angle phi is the angle between the voltage V phasor and the voltage across the resistor phasor. Now using this right angle triangle, I can relate the voltage across the resistor, the voltage given by the source, and the angle phi by looking at the tangent of phi. Tangent phi is nothing else in this case than the opposite side, which is the voltage across the inductor, divided by the adjacent side, which is the voltage across the resistor. Each one of these voltages can be written as the current multiplied by the inductive reactance, or current multiplied by the resistance. We can get rid of current, and we can rewrite tangent phi as, don't forget, the inductive reactance can be written as the angular frequency omega multiplied by the inductance L divided by R. And as you can see from this equation, we can find the resistance as angular frequency omega multiplied by the inductance L divided by tangent phi, where phi represents 30 degrees. All you have to do is plug in the numbers. The angular frequency is 200 radians per second. The inductance is 500 millihenries, or 0.5 henries, divided by tangent 30. And then you get a value for the resistance of 173.2 ohms. Now for the second part of the problem, we need to find the amplitude of the output voltage. Well, the voltage out, which is the voltage across the resistor, divided to the voltage in, which is the voltage across the source, is nothing else than, if you look in this triangle, cosine phi. Cosine phi is the adjacent side voltage across the resistor, divided by the hypotenuse, which is the voltage across the source. From this equation, we can find the voltage out, or the voltage across the resistor, as the maximum voltage across the source multiplied by cosine phi. Maximum voltage across the source is 10 volts, and the phi angle is 30 degrees, so the maximum voltage that can be collected across the resistor is 8.66 volts.